Bismillahirrahmanirrahim. Welcome to the Structural Engineering Software Application class, lecture number 14. In today's lecture, I will discuss application of Sigma W feature of Geostudio. Okay, the lecture outlines are objective of the lecture, application of Sigma W, example on load or deformation analysis by using Sigma W, then class task for student practice. Lecture objective. By the end of this lecture, the student will be able to perform stress and deformation analysis of earthquake structure by using Geostudio. Now, application of Sigma W. Sigma W is a powerful finite element software product for modeling stress and deformation in earth and structural elements or materials. And it has comprehensive stress strain formulation which make it possible to analyze both simple and highly complex problems. The stresses and or the pore water pressure from Sigma W analysis can be used directly in slope W to do the stress based stability analysis. Okay, in Sigma W, many constitutive soil model enable you to represent a wide range of soil or structural material. Sigma W can model almost any stress or deformation problem, including the settlement of footing, fluid filled tanks, or earth structures, deformation within or underneath an embankment or earth dam, and you can also perform lateral movement of braced or anchored excavation and surface settlement around the excavation. Similarly, you can perform volume changes resulting from pore water pressure changes, and you can perform soil structure interaction analysis, and you can perform fully coupled consolidation analysis, and you can perform permanent deformation resulting from strength loss, and you can also perform strength reduction stability. Example on load deformation analysis. Okay, in this is a example I will determine the pressure distribution beneath the round footing of water tank given below. Right, this is the water tank, and the width of water tank is 10 meter, and the load of water tank is 100 kilopascal, and two different layer of material is there below the water tank. And I will discuss how to solve this example in Geostudio by using Sigma W feature. Okay, the following procedure will be used in the definition view. Firstly, I will create a new project, then define analysis, then set view grid preferences option, then define geometry, then sketch axis, then define point line for region drawing, then draw region, then define and draw material, then define and draw boundary condition, then draw mesh property. Okay, in the second step we'll solve this example, and at the final step we will display different results. Okay, first step is to create a new project. So when you open your Geostudio software, so this window will appear. From here you will click on the new, and then you will set your page size, and then click on create. So define analysis window will open. Right, from here you will add Sigma W load deformation analysis type, and load deformation analysis tab set or enter the name of analysis here, and then you will set the analysis type, that is the load deformation. And in setting tab you can set your different information like initial stress condition and initial pore water pressure condition. In this particular example we will choose none for initial stress and initial pore water pressure condition. Right, and then in step 3 set grid and different units. Right, so I will set the unit and grid spacing accordingly. Then step 4 is to define geometry, where I will define geometry. For that, go to define, then select geometry property. So this window will appear. From here I will choose asymmetrical or asymmetric option, and the total angle, the central angle will be 360 degree. So I want to perform analysis asymmetrically and it will give result in all three 360 angle. Okay, step 5 is to sketch axis. For that, go to sketch, then choose axis. So this window will appear. In this window I will define the minimum and maximum values along x and y direction axis. So in x direction I will keep minimum -5 and maximum 40, and increment size will be 5 meter. Similarly, in case of y axis, so I will keep minimum -2, maximum 26 meter, and increment size will be 2 meter. In step 6 I will define points for drawing region. So for that, go to define, then click on points. So this window will appear. So in order to draw a geometry given in the example, so we required 6 different points. So I will define each and every point here in the form of x and y coordinates. And step 7 I will draw region. For that, go to draw, then choose region, and then I will draw a region at a point that is created in this step number 6. Step 8, where I will define and draw material. So in order to define material, for that, go to define, then click on the material. So this window will appear. So I will define a lower and upper layer material. For lower layer material, I will choose the material category total stress parameter, and then material model will be linear elastic total, and then I will enter total elastic modulus constant value. For lower layer it is 4000 kPa, and the Poisson ratio will be 0.45. So I will keep unit weight equal to 0. Similarly, I will enter the elastic modulus E value and Poisson ratio for lower layer as well. Then I will draw material. For that, go to draw, and then click on the material. So this draw material window will appear. From here I will choose the upper layer material, and I will assign it to the upper layer, and then similarly I will choose the lower layer material, and then I will assign to the specific location. And also I will sketch the tank at this location, right? Step 9, I will define and draw boundary condition. So first of all, I will define boundary condition. For that, go to define, then choose the boundary condition. So this window will appear, right? So I will choose the category, and it will be stress strain, right? So by default the software developed these 3 different boundary condition: fix x, fix along x and y, and fix along y. So fix along x means that the displacement along x direction will be equal to 0, means it will be fixed in the x direction, so there will be no movement along x direction. Similarly, for fix along xy, in fix along xy, so there will be no movement along x and along y direction, so you will keep x type x displacement 0 value and y displacement 0 value. So I will define only the tank pressure, right? So for that, I will add another boundary condition with the name tank pressure, and I will choose the kind will be xy stress. So I will enter the load of water tank, and that is in the y direction, but the direction of that load is opposite to the direction of y, so I will keep negative sign with it, right? Okay, by this way you can define a boundary condition. Once the boundary condition is defined, then we will draw the boundary condition. For that, go to draw, then choose the boundary condition. So this window will appear. Okay, from here we will choose the different boundary condition that we have defined in the previous slide, right? And then we will apply it at particular location. In this location we will assign the fix x boundary condition, also assign at this location the fix x, and at the bottom location we will assign fix x and y, right? Okay, for the tank load we will assign the tank pressure at this area. In step 10, we will draw mesh property. For that, go to draw, and then choose mesh properties. So this window will appear. From here we will select the area or the region where we want to draw a mesh, right? And then we will choose, or we will enter the size of mesh, that is 2 meter. And from here in the mesh tab we will define the finite element mesh pattern. So it will be quadrilateral and triangles, right? And then we will enter the ratio of default size 1, right? Okay, by this way we will draw mesh property. Okay, this is the final model and it is ready for the analysis. Then we will go to the step 2 where we will perform analysis. When the analysis is completed, so we can display different results, like we can draw vector. For that, go to draw, right, and choose the vector, so in the direction of the pressure that is moving inside the medium. Similarly, you can draw and label contour for y total stress. This is the y total stress, right, and this is actually the stress distribution beneath the water tank, and the contour shows the similar stress distribution. And you can also draw a Mohr circle for a particular node. For that, go to draw, then choose the Mohr circle and select any node from the region, right. So this Mohr circle will be displayed and it will display the principal stresses and its orientation, and also the stress state of a particular node. Also, you draw graph. For that, go to draw menu, then choose the graph, so this window will appear. From here you can add a different graph, right, and you can draw a graph between any response, like you want to draw for displacement and for x displacement, so it will be appeared here, right, and you can copy graph image and you can also copy graph data and you can also print it. Okay, if in example there is a pore water pressure involved at this location, right, so how we can model this kind of analysis? For that, go to definition view again, right, and then define analysis, then go click on add, right, then choose clone. So it means that it will reuse the solved example data, right. In here we will define the initial pore water pressure condition as a water table at this location, and then we will define and draw water table at the given location, right, and here we will enter the coordinates of the water table line, and then we will draw and we will specify the maximum negative pressure head, and then we will draw the water table at this location, right. Okay, once the water table is drawn, then we can solve this example and then we can display different results. We can display total water head, pore water pressure and pressure head. Now let's see how to solve this example in Geostudio by using sigma w feature. Okay, first of all, create a new project, click on new and then choose size of page, then click on create, right, then enter the title of project. Let's suppose it is project 2, right, then add analysis type. From here it is sigma w and we want to perform load deformation analysis, so choose this one, right. Okay, initially we want to perform load deformation analysis, and I will keep initial stress condition none and initial pore water pressure condition none, right, and the rest of tab value will be as by default, right. So then close the window. Now I will set the units. For that, go to view, units, and I will keep the length unit into meter and mass into kg and force into kilonewton. Then I will set grid and I will keep it 1 meter, right. Now I will define our sketch axis. For that, go to sketch, then axis, right. So I will change the elevation unit will be in meter and the distance will be in meter, right? And I will keep the minimum along x direction is -5 and the maximum will be 40. Along y direction I will keep minimum -2 and maximum will be 28, right? And the increment value will be 5 along x direction and 2 along y direction, right? Okay, x is developed. Now we will define points for region. For that, go to define, then click on points. So we will enter different point over here. So first point at 0 0 location, and second point at 38 and 0 location. Third point is 38 and 20 location. Fourth one at 0 20. Fifth one at 0 25, and the last one at 38 25. So different points are developed now, right, at different location. Right, now we will draw a region by using these different points. So for that, go to draw, choose the region, right? Then we will click on each point one by one, or we can also choose the point by entering the x and y coordinate at this location. If we want to draw, I will choose one point. So for that, enter the coordinate to 0 0, right? Or you can also draw it directly by mouse click. Or you can specify x coordinate at this location 38 20. Similarly, other points, right? So this region is drawn. Now next region, again we can choose this from here, 0 25, then 38 25, then 38 20, then 0 20, and the final is 0 25. So both regions are drawn. Now we will define materials. For that, go to define, click on materials, add new material with name upper layer, and I will choose the total stress parameter in the material category. Then choose material model as a linear model, elastic. Then I will enter the E modulus value, the elastic modulus value. For upper layer it is 3000 and the Poisson ratio is 0.45. Similarly, I will enter or define other material. It is a lower layer, and I will choose material category total stress parameter. Then material model is linear elastic, and the constant value, that is elastic modulus, is 4000 kPa and the Poisson ratio is 0.45. Right, now I will draw the materials. For that, go to draw, material. First of all, I will draw upper layer and then I will draw lower layer. Now for visibility purpose, we will draw a water tank having 10 meter width. For that, go to sketch, and then I will enter the different points to sketch different lines. First will be at -5, then at 25. So the second point will be 5 and at 25, right? So this line will be drawn. Next again I will go to sketch line, and then I will enter the points 5 and 25, and the next point will be 5 at 28. Similarly, I will draw the other line 5 at 25, 28, and then -5 and 28. And similarly, the last line, that is at -5, 28, -5 and 25. Clear? I can label this water tank by choosing the sketch text, and I will enter it water tank, and I will place it here, right? And similarly I can give it dimension. Right? Okay, next I will define a boundary condition. For that, go to define boundary condition, right? So these three boundary condition are there as by default. Okay, and for fixed along x direction, so it will not allow movement along x direction. For fixed along x and y, it will not allow movement along x and y direction, right? So the displacement value will be 0 in both direction. Similarly, for fixed along y direction, it will not allow movement in the y direction. So I will add another boundary condition for water tank load. It is water tank load, and I will choose xy stresses. Okay, the load of this water tank is applied in the y direction, but in the opposite to the actual y. So I will put -100 value, right? And from here we can also set the different color for different boundary condition. Right? Then close this window. Before drawing a boundary condition, I will create or draw a point at this location, at the end location of the water tank, in order to differentiate this area where we can assign the water tank load boundary condition, right? For that, go to draw and then choose point. So I will draw this particular point at this location, right? So now we can assign a separate load or boundary condition here, right? Then I will go to draw, then choose boundary condition, right? So first of all, I will choose the fix x1. So I will assign fix x boundary condition this location, also in this location, right? Similarly, I will assign fix x and y at the bottom location, right? And then I will assign the water tank load here, right? And then I will define a geometric property. For that, go to define geometric property, and I will keep it asymmetric, then closed. Now I will draw a mesh property. For that, go to draw, and then choose mesh property. Then I will select the region where I want to draw mesh property, so I will keep it 1 meter, right? So the mesh properties are drawn. Okay, our model is ready and we can solve it. For that, go to solve manager and start your analysis. This is completed and we can display different results, like we can display y total stresses, right? So these contours give us the different stresses beneath the foundation, right? We can display the show legend, right? It will give you the y total stresses, right? Similarly, we can label the contours, right? Similarly, we can draw a vector. For that, go to draw, click on the vectors along x y displacement, right? So it will be represented in the form of arrows. You can draw a different graph. For that, go to draw, then click on graph, right? So you can draw a graph between any values, like pore water pressure, like displacement. Okay, so the graph will be appeared. You can copy graph data or copy graph image as well, and we can also display the object information, right? The material property and the points, the line, the meshes, and we can also view all the result in the form of report. We can generate a report, right? So this report will display different results, and we can also display a more circle for any node. For that, go to draw and then choose more circle, and from here we will choose any point, right? So it will give you the more circle and the stress distribution in different orientation. Along with load and deformation analysis, we can also perform a pore water pressure analysis. So for that, we will again go to definition view, right? And then we will define analysis, right? And we will define another analysis with the PWP, pore water pressure analysis, and from here we will enter the initial pore water pressure condition as a water table, and then we will draw a water table having some same maximum negative pressure head, and we will draw it at this location, and then we will perform analysis and we can display different results. Okay, once the analysis is completed, you can display different results related to the water, that is water total head, pore water pressure, and pressure head, right? So this is all about the stress analysis by using Geostudio Sigma W feature. Okay, now class practice task number 1, perform stress or deformation analysis for a geometry given below. Okay, thank you so much. This is all about lecture number 14.